x. And now at this point, I can let x go to 1. And I'm not going to get division by 0 anymore, right? I'm not going to get 0 over 0 or anything like that. So this is just, my answer is going to be what? -1. No more limit, right? I'm done. All right, I'm plugging in 1 here. I get this ratio. Boom. All right, what do y'all think? Can you see what I mean by the algebra? I mean, we are now going to be tested on our ability to do algebra. What's your feeling? I need to take the pulse here. How do y'all feel about this? Please raise your hand if you're going to reply to me. I don't want you all talking over each other like that. How do y'all feel? Come on. Oh, y'all are. Look, I've been teaching calculus for a long time, and I understand that this is the hardest part of the algebra. I mean, of the calculus is the algebra, which is why a lot of times you go take this in a university setting, they just put a problem like that up there. They expect you can do that algebra. But I realize that's the piece that you need to see, right? You need to do that. You need practice. You need to get good at it. Your algebra is going to become very good the further you go through calculus. Limit, we're going to use a different variable. U goes to 1. U to the 4th minus 1 over u cubed minus 1. And don't be upset with me. These are not my problems. I didn't make these up. I'm just the messenger. Is that bad? Yeah. It is bad. Okay, it's bad. So it's bad. It's okay. We have algebra. We have tricks. Bad. 0 over 0. Any ideas? I played baseball when I was in grade school. And I'm not a big baseball person. I don't watch baseball, but I can remember sitting there and having that feeling of whether or not I had the guts to take the swing. You know, like, am I going to swing, or if I'm just going to sit here and hope he throws balls all day, right? And like that feeling of, you know, are you actually going to take a swing at this? You know, you can sit there and look at it, but it's better for you to strike out, to swing and try algebra, and it fails, and you just throw it, you know, ball the paper up and throw it away and start over, than it is just sit there and just look at it. So you have to swing, right? You're gonna fail more than you're gonna succeed in this class. Yes.
So it could be like difference of squares on top.
Difference of squares on top. Everyone agree that we could do that? Okay.
And difference of cubes on the bottom.
Difference of cubes on the bottom. Okay, so let's revisit real quick the difference of cubes formula, because you may not remember it. Am I going to have to remember that? You should probably now remember it. At this point, you should probably memorize this formula. X cubed minus y cubed. The formula for this is x minus y, x squared plus xy plus y squared. That's the difference of cubes formula. And then there's also a sum of cubes formula. X cubed plus y cubed is x plus y, then x squared minus xy plus y squared. Okay, those are your two formulas. Those should be on your formula sheets. You know which ones I'm talking about? The ones on Canvas that you can print out? Okay, those should be on there. So we're looking at this formula here. Our x is u and our y is 1, right? Okay, so let's try and rewrite this. This is going to be equal to the limit as u goes to 1. Okay, in the numerator, we have difference of squares. That's what I was told, and we all seem to agree with that. So what would that become as a difference of squares? U squared minus 1, u squared plus 1. So we're using the fact that it was u to the fourth means that our first two terms in those parentheses have to be u squared, right? Not u. And then in the denominator, using this formula, this should turn out to be what? U minus 1. And then it's going to be whatever the x was, which was u. So it's going to be u squared plus u times 1. U plus 1 squared, which is 1. That's just applying this formula with u being x and y being 1 and just plugging everything in. Now, did that get us there? Did that do anything for us? We're still getting a bad scenario here. Like if you plugged in u as 1, you would still get 0 here. And you get 0 here, and that would give you 0 over 0. However, yeah, this is still a difference of squares. So you can actually factor this one more time. So I'm going to do that. I'm going to rewrite this limit. U goes to 1. This is going to be u plus 1, u minus 1. Now, can you factor this? Sum of squares. There is no formula for sum of squares. Unless you use complex numbers, but we're not doing complex numbers. So u minus 1, u squared plus u plus 1. And now, at this point, you see you get some cancellation? That's what we're hoping for. We're hoping that the part of this that's creating the 0 will cancel. And we can see that the u minus 1 and the u minus 1 here, that's the bad part. They cancel out. And so we're left with limit u approaches 1 of u plus 1, u squared plus 1 over u squared plus u plus 1. And now, if there's any justice in the world, this should work. We should get a number now. So what happens? We plug in 1, we get 2 here, right? We plug in 1, we get 2 here. So that's going to be 4, 2 times 2. And on the bottom, 3, 4/3. So if we were to graph this function at 1, it would be undefined, but it would be headed towards 4/3 from both the left and the right. Okay. See if these get any harder. Yeah, I like this one. I'm not really big on bonus, but I just thought about something I'd like to maybe offer this semester for bonus. I'd like to encourage you all to form groups outside of class to go sit down and do your homework and study together. So if you have a group that meets on a regular basis, I want you to keep a log of the people that meet and what days and what times you meet, and keep it all on a sheet of paper. Have everybody sign off on it. So if you all go to sit and meet, just have everyone sign a sheet, put the date, put the time, and then at the end of the semester, I want you to hand me those sheets. And that will be considered as extra credit. All right? But that means you have to go find some people to study with, and that's on you. All right? So, and it has to be people from within this class. That way we can't be like your best friend who's an engineering major already. Question? No? All right, next one. Limit x approaches 9 of root x minus 3 over x minus 9. Is this bad? Okay, if you have an idea of what to do, I want you to raise your hand. I won't call you out, but I just want to see how long it takes someone to have at least an idea of what they want to do. You have an idea? Okay. Just move that 3 down. Sorry. So 1 person so far? 2 people have an idea? Okay. 3. Okay, 4, 5. Let me supply you with a hint. Remember I said normal algebra versus calculus algebra? Showed you an example a little while ago? See if that helps. Yeah? Okay. Okay, so of those of you who have said you have an idea, anyone want to verbalize the idea? I'll let you go. I haven't heard from you that much.
Do what you said earlier, like do the root plus 3.
Okay.
And then root minus 3 on the bottom.
So you're looking at the denominator x minus 9. You're actually going to factor that using difference of squares. And if you do that, you're seeing that that's actually going to create what's up top? Yep, that's exactly what you want to see. You want to see that x minus 9 can be factored as a difference of squares, specifically because that is one of the factors. So let me write out. We know this is bad, 0 over 0, that's bad. So we come down here, we write limit, x approaches 9. We have root x minus 3 on top, but on the bottom, it'll be root x plus 3, root x minus 3. And what does that give you? Cancellation, right? You get this cancellation. I think I'm going to switch to this blue marker. It's a lot better. I'm going to rewrite the limit. What's left on top? 1. Don't forget the 1 on top. And on the bottom, you have root x plus 3. And then at this point, replace your x with 9. And root 9 is 3. So you get 3 plus 3 is 6. You get 1/6. Good. Now, I'd like to show you another way. Did anyone have a different approach? Ah, good. Yes, that's the second approach you could use here. So let me go back up here. This is another approach, and it doesn't seem like this would work, but it's actually one of those tricks that we're going to have in our bag. You could try multiplying this by 1, but what you use is the conjugate of this. Now, the conjugate of something, if I give you an expression, a plus b, its conjugate is a minus b, okay? If I give you an expression a minus b, its conjugate is a plus b. So all you're doing is changing the sign between them. That's what a conjugate is. So if I have root x minus 3, if I miraculously multiply this by its conjugate, root x plus 3, on the top and bottom, something really amazing happens here. So let me show you what happens. In the numerator, if I multiply these two together, I have to do like a FOIL, don't I? And so what this becomes, I'm rewriting the limit. Notice I'm rewriting the limit. What does that become if I multiply that out on top? Root x times root x is just x. And then what about the middle terms? They're going to cancel. Because I have a minus and a plus, and they're identical, they're going to cancel out. You could verify it yourself. Root x times 3 is positive 3 root x. Negative 3 times root x is negative 3 root x, so they cancel. So the only thing left is the negative 3 times 3, which is negative 9. So we have x minus 9 on top, right? And then on the bottom, do not multiply these together. Just leave them split. It's x minus 9 times root x plus 3. You see that? And now what happens is these go away. And aren't you left with 1 over root x plus 3? which is the exact same thing we just got. Two different approaches to the same problem, get to the same result. 1/6. Did anybody have an approach different than that? I don't think there would be a nice approach other than those two. Those are probably the two most common approaches you would see with that. All right, I like that. Good. We'll do one more. And remember that what I've demonstrated here in class is in no way a comprehensive demonstration of this. You have to get in there and do this by hand. And the homework will give you a lot of opportunity to practice. And with my homework solution videos, you'll never be stuck, right? All right, this one right here. Limit x approaches -3. This one just looks bad. 2 minus the square root of x squared minus 5 over x plus 3. All right, do we have anything bad going on here? Okay, -3 squared is 9, minus 5 is 4. Square root of 4 is 2. 2 minus 2 is 0. So we have 0 on top and 0 on the bottom. We can't do what we did last time where we try and use that, like split this up on the bottom as like, factors, because it's not even a difference, so we can't do that. So, right? I want to quit, Mom. I don't like baseball, Mom. So you got to take a swing. Absolutely, let's try it, right? So this is us taking a swing. We are going to try the conjugate. And the conjugate is really a powerful tool. And one thing that should always kind of like make you think conjugate is when you see that root and you see two terms like this. Now, unfortunately, the conjugate is going to look really ugly, all right? It's going to look ugly. But, nobody said it had to be pretty. So I'm going to rewrite this. 2 minus root x squared minus 5 over x plus 3. Then times. Now here comes my conjugate. My conjugate is going to be what? 2 plus root x squared minus 5. And then on the bottom, 2 plus root x squared minus 5, like that. So I've introduced that very clever 1 to the problem. And just remember, when you multiply the top, you have to actually do like a FOIL of that. And always know that your middle terms are going to cancel. That's what's so nice about the conjugate, is that when you're done multiplying, the middle terms always go away. So all you're left with on top is the 2 times 2, which is 4. Hey, I'm writing limit again. Look at that. So what do I get on top? I get the 4 on top. Now this one's a little tricky. You got to do these last two together. So the root and the root together are going to wipe the root out, aren't they? But you have a negative and a positive, which means it's going to be negative. But there's 2 terms under the root, right? So it's going to be minus, and then you better put the x squared minus 5 in parentheses. If you don't do that, it's going to mess up the whole problem. Do y'all see that? This is what's under the root. We had to square those roots so the root went away, but then there's a minus out in front that will pass through. Then on the bottom, most of the time, you are not going to multiply this bottom one out. Because isn't this the thing we want to go away? Isn't this the factor we're trying to cancel? So don't start to mix it up with this, because then you're going to lose it. It's going to vanish into the product. You're not going to see it. So just leave this as x plus 3 times, in parentheses, 2 plus root x squared minus 5. Now, have we accomplished anything here? Have we? What about that numerator? What does this become? If I distribute the negative through, what does that become? You get 4, and then you'll have minus 5. That's going to be plus 5. So 4 plus 5 is 9, right? 9 minus x squared? Isn't that 9 minus x squared? So I'm just going to write that up here. 9 minus x squared. That's the top, isn't it? Now what? That's a difference of squares. These problems are carefully crafted in a laboratory by mathematicians who are trying to cause you as much suffering and pain as possible. So they make them so that they work out, all right? So the top factors how? Be real careful here. How does that factor? How does this factor?
Negative x plus 3 and x minus 3?
Hold on. Say it again. What?
It would do like the negative x plus 3 and then x minus 3? Or no?
It's going to be x minus 3.
It's negative
I
x
think-
plus 3 and then x.
Why are y'all okay?
X plus 3.
I think I agree. I agree with y'all, but why aren't y'all just doing 3 plus x, 3 minus x? Like, to me, that seems like the most natural. I mean, yes, that is negative x plus 3 and x plus 3. That is, but like, why not just use the formula? That's something squared minus something squared. These are the two factors, right? Right? That works. So I'm going to stick with that. I'm going to go 3 plus x. I'm not saying what you said was wrong. I'm going with what I think is more natural to see, which is this goes to this. And then on the bottom, oh yeah, we got lucky. We didn't get lucky. You see them? There they are. Those are the same factors. Exactly the same factors. And they cancel. And this time, I'm not going to rewrite the limit, okay? I'm just going to go straight to the answer now. I'm going to let x go to negative 3. Now, if you do all this work, don't mess the plugging in of negative 3. Don't mess that part up now, right? Like, don't be like, that's 0, right? That's not 0. It's 3 minus negative 3. 3 minus negative 3 is 6. So the top is 6. I'll have to put it over here. The top is 6. And then over on the bottom, we had negative 3 here. We were squaring it. That's 9. Take away 5. That's 4. Square root of 4 is 2. 2 plus 2 is 4. So the only thing left on the bottom is 4. And so this is 3/2, reducing the fraction. All right. Got about 20 minutes, a little less than 20 minutes. Move on to the last part of this section. So I guess we swung at that one, right? Got a base hit. Maybe we'll keep playing. All right, two very important limits. You need to know these. This one is by far more important than this one in terms of this one shows up a lot more than this one does. So let's just real quick look at this. Limit as x approaches 0 of sine x over x. So let's try direct substitution. Let's just see what do we get when we plug in here. If we plug in, sine of 0 is 0. So we need to start thinking a little bit about pre-cal and trig. When I ask you what sine of 0 is, I hope that what you're doing is you're mentally visualizing a unit circle, and an angle of 0. And because it's sine, you're looking at the y-coordinate there. I'm hoping that's the way you're looking at it. If you're looking at it a different way, then I hope you know your stuff. All right, and if you need help with any of that, you can come talk to me. But sine of 0 is 0. What's cosine of 0? 1. What's sine of 3 pi over 4? Root 2 over 2. What's cosine of 3 pi over 4? Close? Negative root 2 over 2. Okay, so look, you might want to go back and review this a little bit, but what we don't want in this class for sure is to have you breaking out your calculator to try and figure out what sine of 0 is. Sine of 0 is 0, right? On top, it's headed towards 0. Bottom, well, x, that's just 0, right? This is bad. If we were going to try and work this out, there is no algebra. There's no trick that I'm going to be able to use to convince you that this is 1. There's nothing that we're going to be able to do. So for now, you are going to have to trust me that the answer is 1. Now we will prove it later, okay? We will prove that it is 1 later, but it's kind of like, let me try and think of an analogy. Let's say that I have, I'm horrible with analogies, but I'll try. Let's say that I'm trying to drill a hole into a piece of wood, all right? And all I have is hammers and nails, and I don't have a drill. I could, if I become proficient enough, use my hammer and screwdrivers to build myself some sort of drill, and then come back and use those. So I use the hammer and the screwdriver to build a tool that I can come back and do the drill with. Does that make sense? We are going to actually build a tool that will allow us to come back and do this. But for now, we can't do it. The tools we have are not enough. That makes sense. Okay. Not a good analogy, but I'm sure you could come up with a better one. So everyone needs to know that the limit as x goes to 0 of sine x over x is 1. And now this one, if you do cosine of 0, you get 1. 1 minus 1 is 0. So on the top you get 0, and on the bottom you get 0. And this limit is 0. But again, can't show you why. So please memorize those. And I actually want to show you these two limits a little bit different than the book shows it, because I don't really care for the book's explanation. I take that back. I don't think that they go into enough detail. So I'm actually going to expand on this a little bit more, okay? Here's the way I want you to see that limit. I mean, memorize that, okay? But I want you to see it this way. Let's say you're taking a limit, all right? And let's say you've got something here. It could be x, t, w, v, it doesn't matter. And that's approaching something, okay? I'm not even going to tell you what it's approaching. It could be approaching 0, it could be approaching 2, it could be approaching pi. Does not matter what that's going to. With me? And then over here you have sine, and then inside sine you've got some junk, all right? And when I say junk, it could be anything. It could be x, it could be x squared plus 1. It could be natural log of x minus 5. Whatever it is, it's junk, okay? And then you divide that by the same exact junk. Okay, so when I say junk up here, I'm talking about the same exact junk that I'm talking about up there. So like here, what was our junk? X, 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 right? Okay. Then this answer is going to be 1, all right? So long as junk goes to 0. All right, let me see if that makes any sense, what I just put up there. I'll give you an example. Limit, that pen is junk. Limit x approaches 3 of sine of x minus 3 over x minus 3. What is that limit? 1. Now, why is it 1? Because what's in the sign, what do we call the thing that's inside of a function? We call that its argument. The argument of this function is x minus 3. And down here, we have the exact same junk. It matches exactly, right? And then the kicker, does the junk go to 0? So if x goes to 3, is that junk going to 0? Is that junk going to 0? Yes. The answer here is 1 then. With me? The book doesn't do that. They just give you this formula and then they say, okay, go try and do this. The big thing is whether or not this piece and this piece match and whether or not they're both going to 0. Let me give you another example. I'll do it, we don't need that. So how about this one? How about limit x goes to 3 again, sine of x minus 3 over x squared minus 9. Is that 1? Think so? What would make you think maybe not? Extra, what do you mean? So do these two things match? Is this junk and junk right here? Do the junks match? They don't match. In order for this formula to work, these junks have to match. Maybe I need to actually state that so that you don't make that mistake. These must match, okay? Those match. If they don't match exactly, then the formula breaks down. So the answer here is not going to be 1. However, we can do some algebra here. For this, we could do limit x approaches 3, and then we could do sine of x minus 3. Then on the bottom, that's a difference of squares, x plus 3 times x minus 3. We agree with that? But it still doesn't look exactly like this. So I'm going to take it one step further. And you just tell me whether or not this looks like a legitimate algebraic move. Is that the same expression? Just properties of fractions. If I multiply these across, 1 times that, that's this, right? And this times this, well, that's that, right? So all I did was just split it apart. Now the question becomes, if you believe that this is a legal move, then you can look at this as being, this is one function, and this is a different function. Remember the limit laws told us that if we have a limit and 2 functions being multiplied, we can do each limit individually? So why don't you do the limit of this? Now what is the limit of that one? 1. We already know that because now it matches perfectly. So this is going to go to 1. That's going to go to 1. So this is equal to no more limit because I'm taking the limit. That goes to 1. Then times, this goes to what? 3 plus 3, right? 6, so 1/6. So your answer is 1/6. The answer is not 1, it's 1/6. See how that worked? All right, I think we're ready for a fun one. I know these haven't been fun enough. This one, I promise this one will be fun. Sine of junk over junk goes to 1 so long as the junk matches up and they both go to 0. All right, just as a little warning on this example, if this is the first time you've ever seen this, this is going to be really weird. Limit as x approaches, let's just go to 0 to keep things simple. Sine of pi x over sine of 5x. This may be the last example we do. What are we getting when we plug in, when we let x go to 0? Pi times 0 is 0. Sine of 0 is 0. 5 times 0 is 0. Sine of 0 is 0. So we are getting 0 over 0, right? So this is headed towards 0 over 0. But there's no algebra that I'm going to be able to do here. So this again is one of those times where I'm going to show you, and then the first time you see it, you're like, oh, wait, yeah, I guess I could have done that. Oh, wow, okay. Now I know. All right, first of all, do we agree with that? I haven't changed the problem, right? All I've done is I've peeled this fraction apart to make it into two pieces. Now this does not go to 1, right? Because I would have to have what down here for it to go to 1? A pi x, right? I would need a pi x down here. Which of these two is actually causing the biggest problem? Is it the fact that this is going to give you 0 over 1? Or is it the fact that this one gives you 1 over 0? It's the 1 over 0 here, right? So watch what I'm about to do. This is where things are like, what? Okay. That's that red marker that doesn't come off the board. Okay. Okay, I just multiplied by 5x over 5x, which is 1, isn't it? Now, why in the world would I do that? Because I'm not going to use this marker because it won't come off the board. So why would I do that? Let's see. This is why. Because if I rewrite this, limit x approaches 0, and I'm sorry, my markers are all dying up here on me. Then I have sine of pi x over 1 times 5x over sine 5x times 1 over 5x. So again, do you agree with that? Is that legal, what I just did? I took this 5x over 5x and I decided just to move that 5x on the top. Is that legal? Yes? Y'all agree? This is all multiplication up here, isn't it? Multiplication you can rearrange however you want, right? If I have 2 times 3 times 4, I can write that as 4 times 2 times 3. I can write that as 3 times 4 times 2. Doesn't matter how I rearrange things, right? So I decided to slide that over. Now, do you see why I did that, though? What is this? Can I use that fact that it's sine of junk over junk? Do they match? Do they both go to 0? They do match, don't they? But isn't it upside down? So is it okay if it's upside down? Well, it is, but let me show you why it's okay. Do you agree that that's the same as 1 over sine of 5x over 5x? So if I take 1 and divide it by a fraction, that's the same as reciprocating it? So this is the same as this, isn't it? And if I look at the bottom by itself, what's that limit right there? 1. And what's 1 over 1? It's still 1. What I'm getting at is that this goes to 1. This is going to go to 1, all right? So I've actually identified where was the problem. This was giving me division by 0. I introduced 5x over 5x. I slid the 5x over here, did that. I realized that that's going to go to 1 now. It's not going to be division by 0. But do you see I've actually created a new problem? Do you see this 5x over here? If x goes to 0, this is 1 divided by 0. So it's like I patched one hole on the boat where the water was coming in, and then another hole popped up, and I've got water coming in the other side now, right? But I'm going to be clever. And I'm going to go back to this one. And what was it that I really hoped I had here? Like, this would have been okay had what been, I mean, This wasn't really a problem. It was just giving me 0, wasn't it? But if I would have had a pi x down here, then it would have been a 1. If I would have had a pi x down there, it would have been okay. I wish I had a pi x down there. Well, wait a minute. I already have an x down here that's actually a problem, but if I slide it all the way under here, then it's not going to be a problem down here anymore, is it? All I'm really missing now is the what? The pi. Well, I can always throw a pi in here, pi over pi. Right? So now I'm going to rewrite everything. Limit x goes to 0, sine pi x over, now what am I going to grab from over here and slide over? I'm going to grab the x and the pi and take those and slide them underneath here. Pi x. This is still 5x over sine 5x, which I know is going to go to 1. And then times what's left over here. Remember, I pulled some stuff away. So here, what's left? Yeah, okay, so you're doing about, I'm going to just write them as 1/5 times pi over 1. Just so everyone understands what went away. The x went over there, the pi down here went over there, which left me the pi on top here, pi over 1, and then the 1/5. And now at this point, everything behaves well. Everything behaves well. This goes to what? When I take the limit now, sine junk over junk, junk matches, junk goes to 0, right? 1 times. This one, remember, was flipped. That still goes to 1 also, doesn't it? And then times, this right here is just pi over 5. So what's your answer? Pi over 5. So this limit is pi over 5. That's pretty crazy, right? That's a lot of weird stuff happening right there. We're out of time. Did everyone sign in? Okay, if you didn't sign in, make sure you sign in here. Start working on the homework for 1.4. When you get to the problems that involve this stuff, I anticipate you're going to run into some issues. But do your best. You got my homework solution videos. See how it goes. And come back with questions if you have them. Quiz on Wednesday. Have a good day.